Greetings, everybody. Nick DiVirgilio here at the Mojave Factory in Burbank, California. I'm sitting with the great David Royer. Thank you so much for having me at your magic room here. All kinds of great things happen back here.
Even if it is a mess.
That's okay. You're building things. You're building products for people to make music with, and that's a really fantastic thing.
Oh, well, thank you.
Now, how long have you been making? How long have you been making microphones? How'd this all start?
Well, actually, how it started was I got my first decent tape recorder when I was about 20 or thereabouts, and I quickly figured out that Radio Shack grade microphones won't cut it for a semi-pro quality recording, and the deck that I had was an old Ampex, which is anything but a consumer grade machine. I had the experience of being able to take a patch from an AKG C24 directly to the old Ampex, and hearing a professional grade, or one of the best professional grade microphones feeding that tape deck, it was a revelation.
Okay.
And at that point I figured out I'm going to figure out this business. And not long after that experience, I started tinkering with say the little Radio Shack Electret mics, which turned out the actual capsules were not bad at all, but the capsules were being sabotaged by very poorly designed internal electronics. And so that led, before too much time, into my finding genuine condenser microphone capsules. In fact, an early experiment I did was to purchase microphone capsules from AKG, the alternative capsules for the old AKG C60, or CK. The C460 was the really popular AKG small diaphragm mic in the mid to late 80s.
Okay.
And you used to be able to buy the capsules independently. Okay. And by that time, I understood electronics well enough to be able to build a tube-type impedance converting stage to use with the AKG CK60, 61, and 62 capsules. And the results were pretty darned astonishing, but I chose a very bad time to try to start a microphone company because recording studios were falling apart like cans being kicked down a dark alley because of the economic conditions in the late 1980s.
Okay.
So after sort of muddling through for a few years, I joined the service, and I served in the Navy for 4 years as a sonar technician, and then once I got out, I picked up where I left off.
Did that teach you more about microphones and the way they work, being in the Navy and learning that part?
Very definitely, not directly, but being a sonar technician was very helpful because I had to learn about acoustics.
Okay.
And with that training, it was possible for me to read textbooks about acoustics and microphones, and I had the underlying theory down well enough that I could read the text without being flummoxed, and I could sit down and plug numbers into the equations and not be flummoxed.
Nice. Which
made the job of building a microphone considerably easier.
Okay.
And at that point, instead of trying to use an outsourced microphone element, I started for the first time actually fabricating my own condenser microphone capsules. And at the same time, I tried actually at that time, say in about 1993, 1994, I put my paws on the first ribbon microphones, and I taught myself how to re-ribbon them.
Wow.
It wasn't that difficult. The only problem, though, is that I had tinkered with ribbon microphones when I was in my early 20s, late teens and early 20s, and I got nowhere.
Okay.
But when I revisited fiddling with ribbon microphones when I was in my early 30s, I was far more successful. And that eventually led to Royer Labs, but that's a story of its own. But as for Mojave, I had been building condenser microphones starting, well, the very first ones with outsourced capsules, were built, say, as early as 1985, 1986,
Okay.
using AKG capsules. And then after I got out of the Navy, I started fabricating my own capsules. And I was selling microphones under the Mojave name, and then for a brief time, I was involved with another company called DVA, which collapsed because it was mismanaged and underfunded. It was shortly after that, well, I was doing business as Mojave Audio again for a few years before Royer Labs started. And about the time that Royer Labs got going, say 1998, 1999, 2000, that was when the flood of inexpensive Chinese microphones started appearing on the market. And before long, it dawned on me to purchase a few of them and gut the internal electronics and build my own electronics for those microphones. And I was astonished at the result.
Were you surprised to see what was inside the Chinese microphones? Why they made them inexpensive? And how much easier you could improve on that kind of thing? That gave you the inspiration to really go for it at that point?
Actually, the better way to put it is that I'd pretty much figured from the get-go that the capsules would probably be halfway decent, and the supporting electronics would be very poor. That I figured the designs would be skimped, and if there was an output transformer, it would be very poorly designed. And I was proven right in spades. With the early Chinese mics, they had horrible output transformers. And the amplifiers were nothing special. But the capsules were astonishingly good. I wrote an article for the magazine Tape Op, and I was selling a kit for modifying those early Chinese large diaphragm microphones. And those kits were very successful. And essentially, the design that I worked out for the kit, the amplifier from that kit is literally the same as the amplifier in an MA200, resistor for resistor.
Okay.
And I went to a more conventional power supply because with the kit design, I designed it around parts that were readily available and cheap. And it was a very compromised design. It was the minimal parts count, minimal cost that would get the job done, whereas I was more conservative with the commercial MA200. And then, of course, the other microphones in the Mojave line sort of evolved from there.
Very good.
We needed a solid state brand mate to the 200, and I tried prototyping several different circuits. The one that survived the beta testing was a very simple circuit using one field effect transistor and a very good quality output transformer. And interestingly, that same circuit, I used it in the MA101, which is the now discontinued small diaphragm solid state mic, and I'm using the same circuit in the MA301 FET, and it's been quite satisfactory in all three mics.
You were saying to me just a second ago that you use your microphones. You don't just build them. You actually do use them as well.
Absolutely. I think I mentioned right at the beginning that I got my first good tape recorder when I was about 20, and I've been an avid amateur sound recordist for all those years in between. So now I'm using the term amateur in the sense of somebody who does it for love rather than for money.
Right.
The term amateur often connotes being bumbling or incompetent in American English, but I'm using it in the more traditional sense of somebody who does something for love.
Sure.
And as I pointed out at the very beginning of this interview, with good recording equipment and poor microphones, you'll end up with poor recordings.
Right.
And over the course of the last 40 years, I've had the occasion of connecting with some very good musicians over the years, and I've always prided myself on being able to set up two microphones and capture musical lightning in a bottle. And at best, the recordings that I've gotten with various microphones that I've built has been astonishing. I think Dusty and the other people here have heard my best efforts, and they will attest to the fact that it's almost like I'm able to conjure up the performers and put them right in the room with you.
Nice.
And that's with just 2 microphones and a simple stereo recording setup with no signal processing whatever, which I think is a much more difficult job than having all of the modern accoutrements of a recording
Sure.
studio, because basically to do the kind of recording work that I do, it entails, first of all, finding musicians who can play together and play the right notes consistently.
That's important, yep.
And it also entails being able to think through just what the performers are trying to do and to place 2 microphones so that the microphones, without any help from anywhere else, will be able to hear a well-balanced pickup of the group, and the microphones will be able to get just the right balance between the direct sound from the instruments and the ambient sound or reverberation in the room, so that the recording sounds neither too raw and in your face, nor too distant and too muddy. And to manage that is something you don't learn in a day.
Sure.
And I'm still learning, I might add. And I've had my times when I've done live recordings. At best, I've done a fantastic job of catching lightning in a bottle, and other times I've been very annoyed at indifferent playing on the part of the musicians. And then other times I've been exasperated by being forced to accept a less than stellar balance because I had to juggle other considerations. For instance, I could not have the microphones upstaging the performers in front of an audience. So such are the pratfalls of doing the kinds of 2 microphone recording setups that I tend to favor. But in any case, for that kind of work, the very best possible microphones are practically mandatory. It would be like, or trying to use mediocre microphones for the kind of recording work I do would be like being forced to do landscape photography with a camera with a really poor lens.
So David, please, can you go and help us out with the importance of a transformer? Really, what does that do, and how important is it in a microphone?
Okay, well, first of all, let's clear up one little thing about transformers. A transformer is a device that takes an AC voltage at 1 voltage and it'll transform it down or up to either a lower or higher voltage. In electronics, there are 2 types of transformers that are liable to be encountered. In a power supply, you'll almost invariably have a transformer separating the output of the power supply from the AC power line. That's referred to as a power transformer. And if I say I'm talking about power transformers, that's an animal of its own, and it isn't really apropos to the audio side of things, because the transformer only works at the power line frequency, and it does not influence the sound of the electronic device to any significant extent. Now, on the other hand, with an audio transformer, that is a transformer that has an audio signal being passed through it. And the reason we use them is, let's talk about the Mojave MA200 for just a second. The microphone capsule connects directly to a vacuum tube, and the vacuum tube has an extremely high input impedance, which is what you need to be able to connect to the condenser mic capsule, which is a device that has an extremely high output impedance. Now, the vacuum tube gives a far lower output impedance than a condenser mic element does, but you're still talking about an impedance of around 20,000, maybe 30,000 ohms, which is useless for feeding a long cable and interfacing with a professional microphone preamplifier. So with a vacuum tube condenser microphone, you need to somehow take the 30,000 ohms impedance of the tube's plate circuit and convert that down to, say, 200 ohms, which is standard microphone impedance. And with a so-called audio transformer, if you design one properly, it will do that job for you very nicely. It'll do a very interesting thing. To convert from 20,000 ohms down to 200 ohms, you need a transformer with a turns ratio of 10 to 1. You'll have 10 times as many turns on the input winding than you do on the output winding.
Okay.
So in this case, 10 to 1 step down ratio with the output transformer. It'll convert 20,000 ohms right down to 200 ohms. And it'll step the voltage swing down by the same amount. But at the same time, it'll raise the current by the same amount. With a transformer, it always happens that you can't, the voltage and the current can't rise together and they can't fall together. Whatever you do to one, the other will move in the opposite direction.
Okay.
Now, as far as designing an audio transformer is concerned, if you design one well, it will produce little, if any, variation in the sound. However, there are plenty of places where you can go wrong with designing an audio transformer. If you, one of the most serious problems is with a transformer, you have the two windings, two coils of wire that are wound on an iron core, effectively, or a steel core, actually. But the problem is that unless the composition of that steel alloy is carefully controlled, it'll start doing weird things magnetically, which will make the transformer do weird things, as in producing high amounts of distortion or producing poor frequency response. And I could add, too, that another problem, well, with a transformer, one area you need to worry about is distortion. Another problem you need to worry about is poor frequency response. And a third problem, which is a less severe problem, is hum pickup. As far as a transformer is concerned, if you have a poorly designed one, if you have far too few turns on the input winding of the transformer is liable to load down the stage it's being fed from, and that stage will start to complain. And then, to make matters worse, if you really try to skimp on the transformer, not only will the transformer cause the stage driving it to mutiny, the transformer itself can't handle really high-level sounds, particularly at low frequencies.
Okay.
And a beautiful demonstration of this is try to visualize this in your mind's ear. Let's say you're trying to record a concert band, and I've done that many a time. If you're trying to record a concert band, you'll be liable to have very loud brass and very heavy percussion happening at the same time. And with a microphone with a poor output transformer that produces large amounts of distortion, when the orchestra starts to play something very loud with very heavy bass and very heavy high frequencies, particularly brass instruments, happening at the same time, when the transformer overloads, you'll start hearing the bass sounding congested, and you'll start hearing, say, the brass section of the orchestra being slapped around by the percussion. Or another thing that you are liable to hear is that as things get louder, what started out as a relatively clean sound in the mid-range and treble gets rattier and rattier and rattier sounding. And a dead giveaway is, let's say that you have a bass tone that is, say a good example would be if you have a low sustained pedal tone on a pipe organ, and you are trying to play chords farther up in the manuals. If you don't have distortion, you should be able to listen to the tone produced by the note in the pedal, and you should be able to hear the chords, and you won't hear any tearing effects. Whereas with a recording of a pipe organ, if you have bad overload, you'll start hearing the chords in the higher frequencies being ripped to shreds at the repetition rate of the note in the pedal.
Wow, okay.
And that's a textbook case of what's called intermodulation distortion.
So there's quite a lot that goes into this. So getting the right transformer is at the beginning is obviously very important.
It's very important, and I've talked only about distortion, but poor transformers can cause poor frequency response, either a loss of high frequency response, a loss of low frequency response, or a badly humped response with a great big peak in the mid-range and the response falling off rapidly, both at the lows and the highs. And none of those are acceptable professionally. No. And another thing, if you try to take a poor transformer and fix it with equalization before it, you're liable to create as many or more problems as the ones you fix. So yes, the point that you made about the choice of transformers being important, that's absolutely the case. And as a designer, what you need to do is to determine beforehand what the worst case operating conditions are liable to be with the circuit you're going to use the transformer in. And you have to either design or select a transformer that will work satisfactorily under those worst case conditions, and then measure the performance under those conditions. And the equipment that we have in the back room has facilities for measuring intermodulation distortion as well as harmonic distortion. Now, I favor intermodulation distortion measurements because they're more revealing.
Okay.
And the facilities that I have, I can take audio transformers and measure the distortion produced by the transformers combined with the amplifier that they're being used with a high degree of certainty.
Nice. And it seems like from my end, you've figured a lot of this stuff out because your microphones that you make here at this company are fantastic. They sound great in the studio in all kinds of different conditions. So at this stage in your career, after designing a lot of great microphones and getting into the details, obviously very specifically, how much are you designing in this stage of your career? How much do you like to do that part of the job?
Well, that is a very interesting question. I do like getting, I'm kind of like a French chef when it comes to building microphones. I'm always, if I happen to be around a vendor who sells audio transformers, or if I see a source for anything related to microphones, I'm thinking, what kind of a soup can I make of this?
Okay.
And I could add that I do have a microphone in work now that is basically, well, how do I put this? The MA1000 is a wonderful microphone, but my point of departure is that the MA1000 is very, very much a Central European design. It was the microphone capsule was essentially designed by AKG, and the overall circuit design that I did with the MA1000 would have been recognizable to the engineers who designed the AKG or the Telefunken ELAM 251, and making a very good AKG-esque microphone is very nice, but the AKG and Neumann microphones have a few quirks which I am less than happy with, and I was thinking for my next microphone I'll take a more American design approach.
Okay.
And I'm thinking about doing a completely different tube circuit that never was really that popular in Europe or in European condenser microphone designs, and I'm planning on pairing it with a microphone capsule that was originally designed by Sony, which the very earliest Sony mics gave you a choice of an omni or cardioid pattern using vents at the back of the capsule. It had one diaphragm, and it did the pattern switching acoustically. It has a few quirks that are very nice. In particular, it has a very well-controlled cardioid pattern, perhaps better than anything that Neumann or AKG ever accomplished. But the original Sony mics were compromised in other areas, which did not fully do justice to the Sony mic element. So that's what I'm fiddling with now.
That sounds exciting.
Yeah, and it'll be interesting to see how it all transpires.
Fantastic. Well, David, thank you so much for telling us the history, and it was great to be at the factory here watching you test the microphones and seeing all these things being built here. So best of luck for your new project. That sounds exciting. And thank you so much for the relationship with Sweetwater.
Well, you're very welcome, and thank you for all of your support.
We are very happy to have the relationship with you guys.